In this problem, we're going to be writing a series in sigma notation. So there are a couple of things we need to know about sigma notation. And the first is we're going to start with the Greek letter sigma. And there's a couple of things we need. So we need to know the explicit formula. And we really need to know the number of terms that are in this series. And right now, for an integrated 3 or an algebra 2 class, we're typically going to start with the first term being equal to 1, and we're just going to determine if that's going to work for us. So the first thing I'm going to do right here is just determine what kind of series we're working with. And since we have 75 going down to 70, and then going down to 65, you know we're dealing with an arithmetic series here, where the common difference is -5. Now, you really have to worry about that and be careful, because a lot of students want to put that the difference is 5, but the difference is actually -5. So the next thing we can do this all at once right now, is we can use the explicit formula for an arithmetic series, and that will give us both the number of terms if we solve for n, and it'll give us our explicit formula all at once. So all I'm going to do right here is just plug everything in that we know. A sub n is going to be our final term, which in this case is going to be -25. And you can tell that by simply looking and seeing that the last term is -25. Our first term is going to be 75, and you can see that again from the series. Plus, we don't know the number of terms, so we're going to leave that as n minus 1. And we know our common difference is going to be -5. And we can fill all that in. Now we want to simplify this a little bit, because we're going to end up solving for n. So to do that, we're going to distribute the -5 to the parentheses, and that ends up giving us -25 is equal to 75 minus 5n, and be careful here, a negative times a negative is going to give us a +5. Now we can simplify this a little further by combining like terms, and we get -25 is equal to 75 plus 5 is going to give us 80 minus 5n. And then 2 more steps to go. We're going to subtract this 80 so that we can solve for n. So we're going to subtract off 80 here, and we end up with -105 is equal to -5n. Sorry, -5n. Let's fix that. Is equal to -5n. And then we're going to divide both sides by -5. And in doing so, that's going to give us our number of terms, where n is equal to 21. So we know we have 21 terms. Now how that helps us is we can go ahead starting with n is equal to 1, meaning here we go, here's our first term, our second term, our third term, and now we've determined this is our 21st term. So we can go ahead and put 21 up here. Lastly, we need an explicit formula. Well, here it is right here. After everything is simplified, there's our explicit formula. So we know we can get all our terms by simply taking 80 minus 5 times the number's position. Real quickly, and this is just sort of an add-on, you can check your work here to make sure that yes, you have the correct number of terms, and yes, you have the correct explicit formula. So if I plug in 21 into this formula, I should get -25. So let's go ahead and do that. So if I plug in 21, I have 80 minus 5 times 21, and that gives us -25. So we know that 21 being our last term works. And just real quickly, so that I can show you, we could start with n equals 1. If I plug 1 into this formula right here, 80 minus 5 times 1, 80 minus 5 is 75. So we know we can go ahead and start with the number 1. And so there you go. We just wrote a arithmetic series in sigma notation.